Our main goal now is going to be to solve quadratic equations using a method called completing the square. It's going to allow us to solve some quadratic equations that we could not have solved before. Now, here's another example of squaring a binomial and getting a perfect square trinomial by the same approach that we saw just a few moments ago. And our overall goal is going to be to solve the equation x squared plus 6x equals 16. But before we do that, I want to talk a bit more about the binomial squared and the perfect square trinomial. Have you ever wondered why we also call x to the second power x squared? It's because x squared stands for the area of a square. That is, has dimensions, has a length and a width, both of x. So we can interpret 6x to be the area of a rectangle that has dimensions 6 by x. Now we're going to actually split that up evenly, cut it in half. When we did FOIL to multiply something like this out, we would have had 3x plus 3x to get to 6x. Hence, since we're adding something to itself, we're doubling 3x. What we're going to do in this drawing is extend in both directions by 3, and that's going to give us a rectangle here and a rectangle here. Both of them have an area of 3x. The total area of this figure is the x squared plus 6x that we're seeing on the left hand side of this equation. Now furthermore, we know that x plus 3, that quantity multiplied by itself, is equal to x squared plus 6x plus 9. That would mean that if we have this little corner here filled in, then on the one hand we would have overall a large square with dimensions the quantity x plus 3 by the quantity x plus 3. So far, before I fill that in, we had x squared plus 6x for a total area, and now if you lend me a little artistic license, this here is a square with dimensions 3 by 3. So its area is 9 for a total of x squared plus 6x plus 9. That's by adding up the area of these 4 separate parts. On the other hand, looking at it all at once, this also expresses the area. Well, how does that help us solve quadratic equations? I can't use the square root property that we were talking about earlier because, one, I don't have what's being squared isolated, and number two, the thing that's being squared shows up elsewhere as well. However, if I add 9 to both sides, add it on the left, and then on the right hand side, 16 plus 9 is 25. Either by looking at the picture, going from the detailed view to overall, or reading this from right to left. Instead of talking about a multiplication formula, I'm talking about it as a factoring formula instead. Well, that would mean the left hand side here is the quantity x plus 3, all of that squared, and that's equal to 25. That looks like a question we did earlier. Although there's something inside, we only see x in one place, and that place where x is, that whole thing is being squared. So we can take the square root of both sides. Like I said, I'm going to leave out writing the square root on this side because we know it's going to cancel the squaring. We've got a nice perfect square on this side. And what do we need to remember? This is where, if we were with a classic, everybody go, the plus minus sign. And so, yep, there we go. There's the plus minus sign. X plus 3 equals plus or minus 5. We could isolate the x by subtracting 3. And then when you split that into the two cases, negative 3 minus 5 is negative 8. Sorry about that. Negative 8. And then negative 3 plus 5 is positive 2. Feel free to go back and plug in each one of those everywhere where you saw x in the original equation one at a time, and you'll see that you're getting the left hand side is also equal to 16.